Welcome to the era of big data, where global data creation surged to roughly 97 zettabytes in 2024 and continues accelerating. Most of that growth happened in just the last 2 years, and the market is booming into the hundreds of billions. Every person now generates data continuously, which changes how businesses operate, compete, and make decisions at scale. When we ask what big data really is, we look at 4 key qualities: immense volume, blistering velocity, huge variety, and the need for veracity. Daily streams of tweets and emails, mixed structured and unstructured sources, and the demand for reliable, accurate insights all define the challenge and the opportunity of modern data environments. Data collection has evolved from punch cards in the 1880s to relational databases in the 1970s, then to Web 2.0, the 2000s, and the explosion of IoT in the 2010s. The visual timeline shows how storage, media, and processing models changed, alongside surging data volumes, making today's cloud and edge systems a necessity rather than a luxury. Modern data infrastructure is driving dramatic cost and capability shifts. Cloud storage costs have plummeted. Roughly 60% of corporate data now lives in the cloud. Enterprises routinely manage hundreds of terabytes, and most workloads run in cloud environments. The data center imagery underscores how scalable, centralized infrastructure supports global applications and real-time analytics. A toolbox of big data technologies powers this shift. Hadoop-enabled massive batch processing, Apache Spark sped analytics up dramatically, NoSQL databases scale for billions of transactions, and AI integration is now mainstream. Together, these technologies let organizations process petabytes of data faster and extract actionable intelligence for products and operations. The economic impact chart highlights a striking reality. Big data can massively boost the global economy compared with narrower technology segments. This visualization shows that investments in data and analytics deliver outsized returns, fueling growth across industries, improving productivity, and creating new revenue streams and efficiencies for businesses worldwide. Across industries, big data is transforming how work gets done. In healthcare, it enables predictive treatment and faster AI-assisted diagnosis. Retail leverages personalization to lift ROI. Manufacturing reduces defects through predictive maintenance. And finance detects fraudulent transactions in real time. These examples show measurable improvements in cost, quality, and decision speed. Real-world applications make these benefits tangible. Streaming services save significant sums with recommendation engines, logistics companies cut fuel use via route optimization, precision agriculture boosts crop yields, and predictive policing pilots have reduced crime substantially. The right data strategy translates directly into operational savings and better outcomes for customers and communities. Security challenges remain a major concern as breaches and incidents proliferate. Recent data shows thousands of reported breaches exposing billions of records, with high average cost per incident, and most enterprises experiencing some form of risk. Protecting personal data, measuring financial impact, and managing enterprise exposure are essential priorities for any data program. Ethical considerations must guide big data adoption, from formal AI frameworks to bias mitigation and regulatory compliance. Many organizations are still building ethical guidelines while studies show algorithmic bias and rising consumer privacy worries, and regulators are issuing substantial fines. Balancing innovation with responsibility is crucial to maintaining trust and avoiding harm. Data privacy regulations now shape global operations, with rules like GDPR in the EU, CCPA in California, LGPD in Brazil, and PIPEDA in Canada, each imposing penalties and compliance expectations. The table of regulations reminds us that legal frameworks differ by region, so multinational data handling requires careful policy alignment, transparency, and robust controls to avoid costly violations. Looking ahead, emerging technologies will redefine what's possible. Quantum computing promises enormous processing leaps. Edge computing brings low-latency processing close to data sources. Federated learning enables privacy-preserving model training, and 6G networks aim to deliver unprecedented transfer speeds. Together, these trends will unlock new categories of data, applications, and services. Preparing for a data-driven future means investing in education, workforce development, and talent retention. Massive numbers of new tech roles will require data literacy. Many companies report skill shortages. Data scientists command premium compensation, and closing the skills gap is vital. Organizations that train talent and foster continuous learning will be best positioned to capitalize on data opportunities. To wrap up, the key takeaways are clear. Data growth remains exponential. Ethics must accompany innovation. Data literacy is essential across the workforce, and enormous opportunities lie ahead alongside real challenges. Embracing data, thoughtfully balancing strategy, skills, and governance will determine who leads in the next decade of digital transformation.